So welcome to the session of band pass filter. So now I am going to discuss band pass filter. Till now we have completed low pass filter, high pass filter. Now we will study band pass filter. Okay. So as you know the definition of band pass filter, it is a filter which is going to pass only specific band of frequencies and it is going to stop the remaining all frequencies. Okay. So as soon as I told specific band of frequencies, I am going to have two cutoff frequencies. One is lower cutoff frequency, another one is higher cutoff frequency, due to which I am going to get a bandwidth which is defined as fH minus fL. Okay. So now this particular band of frequency and this particular constant gain is obtained by making use of an combination of two circuits. One is high pass filter and an low pass filter. What it is, let us discuss. Before that, we will see what are the types of band pass filters that are available. We are having two types of band pass filters. One is wide band pass filter, another one is narrow band pass filter. Okay. Now this particular classification is made purely based on Q factor, Rn quality factor, also called as figure of merit. It is defined as merit. It is defined as a measure of selectivity. So what is that? Selectivity is, in other terms, I will tell, if more the Q, so greater the selectivity over here. So greater the Q value, greater is the selectivity. That means, so more the Q, narrower the band you are going to observe. Now this particular band is a flat band. Narrower band means it will have sharp edge. It will have sharp edge. Therefore, if quality factor, that is Q, is less than 10, it is called as wide band pass filter. If the quality factor is greater than 10, it is called as narrow band pass filter. Okay. So now we are having a relationship between Q bandwidth and another name called as center frequency. Now this center frequency FC is nothing but mean frequency in the form of product of FH and FN. So you can observe this, you have already done mean value while calculating square root of F1 into F2. Now it is FH into FN. So now the relationship between these three is given as Q is equal to FC by bandwidth. So where bandwidth is nothing but FH minus FN. Okay. Now this is particular things that is required to study the two types of band pass filters, that is wide band pass and narrow band pass. In our today's session we will discuss wide band pass filter. Okay. So wide band pass filter, as I told, wide band pass filter in the frequency response, the pass band is wide. The pass band is, or the constant gain is, we are having wide. So that means flat. Okay. So now to study this, the circuit is designed using a cascaded structure, using a high pass filter and a low pass filter. So there are two stages. One is high pass filter stage, another one is low pass filter stage. It is a cascade between high pass filter and low pass filter. Okay. In general, I will discuss here. Then I will go with the design over here. You just observe. Now just observe this growing line and a constant value. It is the concept of high pass filter over here. So low frequencies are cut off. Only high frequency are passing, which is going like this. Now because of which I will get a low frequency cutoff range. Okay. So now if I go for a low pass filter, in the beginning itself it is constant. Then in the cutoff frequency it is going to decrease. Okay. So that cutoff frequency is nothing but FH. Therefore, FH is for low pass filter, FL is for high pass filter. Now the I am selecting this pass band using high pass filter and low pass filter. So therefore it is a combination of high pass filter and a low pass filter. Now you can consider first order or second order as a combination. So first order, I am considering a design of first order high pass filter and then first order low pass filter. You can do second order low pass filter and second order high pass filter. Now you just see the circuit is same, nothing but C and R, showing an first order high pass filter which we have already discussed. Now you just see this is a combination of R and C in the form of R dash and C dash, just to bifurcate these two values. Okay. So now low pass filters, same concept. Again, you know what is its gain, what is its characteristics, all things you know. That means designing of wide band pass filter is same what you have designed for first order high pass filter, those values for FL. Now for FH, whatever I have discussed for first order low pass filter remains same. Okay. So now this combination output of high pass filter is given as input to the first order low pass filter, and in the end I am collecting the output. Okay. So now gain obtained from this is cascaded to the gain of the next filter. Now such that the gain is nothing but total closed loop gain, which is referred as AFT, total. So the total is calculated. If it is AF, let us consider it as AF dash, which is nothing but a product, AF into AF dash. Okay. When you come to discuss the gain of wide band pass filter, it is given as AFT multiplied with F divided by FL divided by square root this value. Okay. You just visualize, don't visualize this as a big expression, very simple expression. Now if I remove AFT and if I write AF into AF dash, now you just see AF divided by square root of 1 plus F by FL whole square into F by FL. This 2 along with this 1, it is nothing but equation of high pass filter. Now if you take AF dash without this divided by only this particular equation, now it is the equation of first order low pass filter. Now cascaded, therefore I have combined that equation to form this particular equation. Okay. So now this is a design where you are designing a wide band pass filter such that the designing part of all these things are going to remain same. Now if I ask you what is the design of this, you will tell FL is equal to 1 by 2 by RC. If I ask you what is the design of this, if you tell FH is equal to 1 by 2 by R dash into C dash. So remaining all same, capacitor value same, resistor value designing same, R dash designing same, C dash designing same. Okay. So in the same, and again in the exam don't write sir has explained same. Okay. So now this completes wide band pass filter explanation. I hope you all have followed what we have discussed as wide band pass filter. In the next session we will discuss narrow band pass filter. Thank you.